So the first option is for us to again do a scan versus BIM. However, this time we're doing it based on objects. So we're taking every object separately, let's say a column, and this is what you are going to be doing for your final project. And we're simulating the BIM from each and every one of these objects separately. So we get floor number 1, for instance, column number 1, whatever it is. That is going to be a full object itself, and we go and we find all of the points that are closer to this that satisfy certain criteria. What is it supposed to satisfy? We get those surfaces, every point in the point cloud, we get the distance, and we get that projected distance. 2 criteria here need to be met. One is that the distance between the point and the surface needs to be smaller than your distance threshold. Okay, let's say 5 centimeters, 10 centimeters, whatever it is that is going to be your threshold there. The second part is that that projected point actually has to be inside of that boundaries of that BIM surface. And then if the points that are within the boundaries of that, if you take a look at all of those points, and then you go and you get the area of that covered surface versus the area of that surface, if that amount of coverage is larger than a particular amount, let's say your surface coverage min, let's say 50%, 20%, however much it's going to be. If it's smaller than that, then that surface is not covered. Essentially, it's very sparsely covered. If it's higher than a particular amount, then we say that this is going to be covered. And once those are covered, what do? We perform an ICP with all of the points that have correspondences with surfaces that have been covered. Okay? Okay. So I did a bit of a modification here, and I developed this new algorithm. This time, the modification is instead of doing all of these using your points and projection of the points together, instead of that, we just focus on the boundaries of that. We say for planar surfaces, if I have a planar surface here and a bunch of point clouds that are basically planar, so I have to do a pre-processing for the planar surfaces, I only look at the boundaries of these points, and I take a look at the boundaries of this surface as well, and I get the average distance from the surface to this surface. So I get an average distance, and then I also get an angular difference between these two. If the angular difference is within a particular difference, let's say 10 degrees, 20 degrees, whatever it is, and our average distance, which I have a formula to be able to estimate the average distance as well, is going to be less than also a threshold, okay? What do? I go and I take a look at the boundaries of these points, and then I see whether the boundaries are actually intersecting or not. If the boundaries are intersecting, that's going to be a possible surface. The reason why this is good is because it's very, very fast, and I can actually account for absolutely every one of the surfaces there. And then to reduce the possibility of actually having any type of problems with respect to the assignment of the surface from the point cloud to the BIM, what I also do is I say I will put all of these inside of a linear assignment problem, meaning that if I have a surface that is going to be assigned to more than one surface, you go and select the best one. This way, I basically take the whole point cloud surfaces from the surfaces that I extracted from the point cloud and the surfaces that I extracted from the BIM, and I build a matrix. And then I find what that assignment is. The benefit of this is that it would be impossible to do it directly from the point cloud itself, because prior to it, we weren't looking at it as a surface, we were looking at it as a point cloud. Point cloud is 1 million, 10 million, however many million there's going to be. If I wanted to do an assignment problem, it would be 1 million rows, and then, I don't know, 200 surfaces for the BIM. This time, I'm going to get a 200 by 200 matrix, easily solvable. That's now the difference there, right? So here, I also basically, instead of putting all of the point cloud there, I just put the boundaries there and of the planar surfaces with some, let's say, errors and outliers there as well, you can see. And then I just generated just to give you guys an idea. And then I have some thresholds there, and there I can take a look at the BIM ID. And there are 30 different IDs, so I just put 17. What it does is it goes and it shows where that particular BIM element is, and it does the convergence there. And it gives you the final RMSE. These are in meters, so not in millimeters, I apologize. And then you can see how much those deviations are going to be. So the blue is the original, and the red is the fitted one. That is for that other surface there. So you can see that there was some dimensional mismatch, but it's very fast. It's almost instantaneous compared to, and this is both visualization and analysis. And then I represent two metrics here. So the final RMSE is how well the red matches the BIM, okay? The blue here, how much and the total error is how much the blue and the red are different. That's what this is. So this is, let's say, 20, and then I give different metrics. So I say, okay, for detection, for coverage, for accuracy, I give an error bar. This is, for instance, for detection. The ones that are red were not detected. The ones that are green, detected and in tolerance, and the rest were out of tolerance. In this case, I put the tolerance value very, very low. I said, if your total error is more than 3 times the final RMSE, that's out of tolerance. You know, I did something like that, and I could have put, I don't know, 5 centimeters, and you know, half of these would at least, you know, be within tolerance, right? So that's what that is. I give 2 metrics. One is how well the red matches the BIM, and the second one is the total error. How much did the original point cloud move? And that identifies whether you're in tolerance or out of tolerance. Okay, so failure modes of scan versus BIM. The original scan versus BIM, what does it do? It takes a look at your point cloud. It goes and from the center of the scanner, goes to every point and extends it and says where it's going to be basically intersecting that surface. In our case, I've basically said, because we don't know the location of the scanner, we just do a projective transformation, okay? And we, instead of actually looking at, because we also do not know the location of the orientation of the planar surface of the point cloud, because we don't want to do the pre-processing there, I say, okay, for every point, we just basically go and do a projection that is orthogonal to that surface. Same idea. At the end of the day, there's not going to be any correspondences here, right? So if we want to have this BIM surface and this point cloud that corresponds to this BIM surface, are there any correspondences between the point cloud and the BIM surface? Using the original scan versus BIM, if you know the location of the scanner, you just put that from the center of that, you basically extend that ray to a point and then extend it. Wherever it hits the surface, that's going to be your surface if it's smaller than a particular threshold. And then within the boundaries, that would be a particular surface. In our case, I've simplified this. I said, okay, if you have a point there, let's say this is a point here, and then you have a surface here. I go from this point. I don't care what the orientation of these points are because this requires a pre-processing, right? The only thing that we have is a bunch of points, right? I go from this point. I go and I project it onto all of the surfaces that are there, right? And see if this point has any correspondence with these surfaces. Does it have any correspondences? This is from the top. We're looking at it. Right? Does it have? Because if we project it onto this surface, imagine even if this distance is correct, this projection is outside of this surface, right? So there's no correspondences here. What about this one? There's a correspondence. This surface is from here to here, right? So the projection of this onto this is this, right? Yeah, makes sense. So it would only work in a very, very close proximity. In general, as a rule of thumb, if they have intersection, it is possible for it to be recovered. If it doesn't have intersection, the possibility reduces significantly. And it's very subjective whether it would be covered or not, or would be recovered or not, right? So as a rule of thumb, if that point cloud is basically moved towards that, closer, where there's going to be some, let's say, intersection, this now has a possibility for it to be recovered. Make sense? If it's far, forget about it. My method does a better job of this because I have estimated the orientation of these prior to it as a pre-processing stage. So I have more information to be able to match these two together. But that also only works for planar surfaces very well. For non-planar surfaces that are a mix of different things, let's say these guys, it's still not sufficient. I have another method for that, which I'm going to be talking about it. But the other side of it is also how well you're going to be estimating your STL model. I mean, this is an exaggerated situation with this. This never happens. But what I'm saying is, in the STL, if you're looking at the STL rather than the geometry, how do you define a cylinder? Cylinder is a circle, right? How many of these small planes are you going to be estimating to estimate a cylinder? If you're getting a cylinder directly, well, yeah, you know, cylinder, we talked about it, you can define it with 7 parameters. But if you're doing it in an STL format, what does that mean? That means that you're going to have a bunch of triangles. Or if you have a circular shape like this or an arc, this needs to be defined by a set of planes, right? Because of that, there's some errors associated with it. And the more accurate we want to actually estimate that particular curved surface, you're going to have more of these. That means that I'm now having to do the point to plane correspondence to 100 more planes.